Page 496, number 10. We've been given f of x and g of x, and we're going to find the quotient of f divided by g. It says state the domain and range of the combined functions and any restrictions. So the big one is the restrictions. So when we take a look at a, we have f is tan and g is cos. And what I end up with is tan divided by cos when I divide those two functions. The important thing is to recognize where the restrictions lie, and that's when the denominator is equal to 0. Or in other words, when cosine is going to be equal to 0, because we can rewrite this expression as that's going to be sine x over cosine squared x, okay, when I combine those functions. So where the cosine is equal to 0, we're going to have vertical asymptotes. So at negative pi over 3, I put them on the table already. Negative pi over 3, negative 3 pi over 2, negative pi over 2, at pi over 2 and positive 3 pi over 2 is when we hit the vertical line to give us a cosine of 0. So those are going to be where our asymptotes are. So I'm just going to maybe start there and draw in my asymptotes. So I'm going to have some asymptotes here, here, here. So we can see that they're going to have an asymptote every pi radians. Okay, so then the other thing is we want to probably find out the zeros. So when sine x is equal to 0, we're going to have a 0 for this function. So sine x is going to be equal to 0 at negative pi, at 0 at pi. So at those points, we're going to have 0. So it's going to cross the x-axis on those parts. And then we probably want to have, and since it's a repetitive function, we probably want to have some coordinates to work with. So I'm going to plug in here a coordinate between 0 and pi over 2, or pi over 4. So when x is equal to pi over 4, we're going to have sine x is going to be 1 over root 2, and cos squared is going to be 1/2. So this works out to be 2 over root 2, or basically root 2, or 1.4. So at pi over 4, we get a value of about 1.4. When we have negative pi over 4, we're going to have negative about 1.4. And we're going to have a graph that's going to follow the asymptotes like this. Okay, it's going to essentially look like a tan graph. And then on this side, we can plug in more points to work this out. But this is because of the squared nature of that denominator, we're going to have the asymptotes going up in the same direction. Okay, so I'll put the coordinates in here. This is going to be root 2, negative pi over 4. It's going to be negative root 2. And we can, again, as we need more coordinates, we can work out more coordinates to give us more details on this graph. But the more familiar you are with the graphs, the less we need to rely on the coordinates.